We will conclude Chapter 5 with Section 5.6, the real zeros of a polynomial function. So let's be sure we understand what we're talking about. Real zeros are the exact same thing as finding the real solutions if you're solving a polynomial equation, the real number solutions, which we've done that. And if you're graphing, it's the same thing as finding the x-intercepts. Right? And they will be real numbers because we wouldn't be graphing imaginary numbers, right? So these are all the same thing. It just depends on the context of the problem, but they all come from the same idea. So this fact is to be kept in mind, that a polynomial function cannot have more real zeros than its degree. So in other words, if your power is 2, it's a quadratic, you cannot have more than 2 real zeros. If it's 5, you cannot have more than 5 real zeros. So the maximum would be the degree of the polynomial. There could be fewer because why? Well, we're talking about real. So there could be some imaginary zeros that we would not be looking for here. So that's why you may not get the full 5, is that perhaps some of them are imaginary. Okay, in section 5.1, we were able to identify real zeros because we had a factored function. So it was already, x minus 3 to the second power times x plus 1 squared, whatever, and we could see the zeros in there. We knew exactly what they were. We had a factored polynomial. But we've got to find out in section 5.6, what do we do if we're given the polynomial in an unfactored form, such as this? How do we find those zeros? We don't have a quadratic formula type formula for third degree, fourth degree, fifth degree. There's no easy way to just calculate what those real zeros are. So we need a procedure for that. And one of the things we'll use, or one way we'll get to that, is by using the remainder and factor theorems and the idea behind that to get to it. So this is what we're doing here in this first example, is showing how those theorems are used, but this is not a complete problem. This is just a point in a problem so we get some understanding. So we're going to learn all the different pieces of a problem that says, hey, here's a high degree polynomial, find all the real zeros. We've got to find all the different steps involved with that, and we're going to look at that in different pieces, starting here with using the factor theorem to determine whether this function has these two factors. So they want us to use the factor theorem. Recall what the factor theorem said. Okay, it says that if x minus c is a factor, if this is a factor of this, then I could plug in c in here and the result should be 0. So if f minus c, if this is a factor, x minus c is a factor, I should be able to plug in c and this into this, and the result would be 0. If it's any other number, then it is not a factor. And remember, that result is also the remainder we get if we did synthetic division. So if the remainder is 0, that's the remainder theorem, right? They complement each other. All right, so if x plus 1 is the factor, what is c? What am I trying to find? What is the 0 I'm trying to find, right? So remember, it's in the format x minus c. So if it's in the format x minus c, then this would be x minus -1. So for this problem, c is equal to -1. So in other words, find f of -1. If it's 0, the answer is yes. This is a factor of this polynomial. If it is no, then if it's not 0, then the answer is no. Okay, so we're going to plug in -1 everywhere we have an x, -1 cubed minus -1 squared plus 4 times -1 plus 3. So -1 times -1 times -1 is -1, right? And -1 squared is +1. 4 times -1 would be -4 plus 3. So now we have a +2 minus 1 minus 4 plus 3. So 2 minus 1 is 1. 1 minus 4 is -3. -3 plus 3 is 0. So the answer for this one is yes. It's a factor because the result f of c was 0. Okay, in part B, what is C? Remember the format is x minus c, so for this problem c is positive 1. Oops, c is positive 1. All right, so let's find out what we get when we plug in positive 1. Negative 2 times 1 cubed minus 1 squared plus 4 times 1 plus 3. So that's just going to be what? Negative 2 minus 1 plus 4 plus 3. Negative 2 minus 1 is negative 3, plus 4 would be positive 1, plus 3 would be 4. So no, x minus c would not be a factor of this. And remember the factors, if this had been factored out, it would be all those little binomials raised to different powers that we saw in section 5.1.